So this question, this midterm test was quite simple, but people messed it up. So first question says, fluorine, chlorine, bromine, and iodine are actually in the same group of the periodic table. So we need to know the group where that thing belongs. And the question says, state the common name. Now, the name they were looking for here is not just any other name. It's a name that is given to the group where those elements belong.
Yes, sir.
We just ended on the name without going as far as looking at the other part of the question. The other part of the question says, and explain why they are called by that name.
I'm sure the rest of the class has forgot why they are called that name.
Yeah, so here you state the name. Allow me to zoom it a little bit. You state the name as well as giving a reason as to why these elements are called by that name. So
Yes, sir.
what could be that name?
So fluorine, chlorine, and bromine and iodine, they are all part of group 7. Group 7 elements are called halogens, and they are called halogens because they form salts. That's what I wrote.
So the name is called halogen, and the reason is because they are salt formers. As simple as that. Or you could say because they form salts. So it's just one. And look at a very simple question, 2 marks were actually being awarded. So they are called halogens because they form salt. Just give me a second.
All right, sir.
How now? 2 years. Oh, okay. Yeah, so they are actually called halogens because they form salts. And then part B says, state the group in which these elements belong. So here you're just actually stating the name. Now here you got state the very group as well as explain the reason as why all these elements fit to be put in that group. And remember here you have to be guided that the group number, you don't write a digit, you use Roman numerals. So what name is given to that group?
The name given to that group is group 7.
Not the name is halogen. But what is the group number?
Group 7.
It's group 7, and the 7 must be in Roman numerals. And what do we follow? What do we follow when placing these elements in the periodic table?
I wrote because they have 7 electrons in the outermost shell.
Yeah, so you need to understand that when you're given an element, when you write electron configuration, there's a lot of information that you can get from that. The information is that the number of electrons in the outermost shell is what gives us the group, and the number of shells occupied by those electrons is what gives us the period. So they are in group 7 because they have, now here you can just use the name, 7 electrons in their outermost, 7 shells. They have 7 electrons in the outermost shells. As simple as that. As simple as that. And then what about C? C says, which of the above named elements is a solid at room temperature and pressure? So being those elements that were given, they have different physical states, but they're looking for one which is a solid.
Yes, sir.
So maybe to start with, we are going to say that fluorine and the chlorine are what? Are gases. Okay. Then bromine is a liquid, and the iodine is one which is now a what? A solid. So right from here, you are able to itemize the things that we're looking for. So which one is a solid at room temperature and pressure? Most definitely we know that it is
iodine.
It is iodine, yes. So it is actually this guy here. Yes, the next question. So that's where we ended with these questions that we had, where we ended. Then number 2, we move on. Can we move on? Okay. Number 2 said the following table shows chemical properties of metals. And these chemical properties I've actually talked about. It's just about the reactivity of these elements with the following stuff, which are air, we know it's oxygen, steam, that's the reactivity of these two, as well as their thermostability. What type of compounds do they form? Are they very stable enough to a point that when you heat them, they do not decompose? Those are the things that the question is talking about. But above all, you also need to understand that when a box is ticked, it means that reaction is possible.
Yes.
And when there is a cross, it means that reaction does not happen. And above all, we say that most reactive elements form very stable compounds that do not decompose. Most reactive elements form very stable compounds that do not decompose. So if you look at this reaction, this part is not possible, and this part is not possible. They do not decompose. And yet, this metal can react with air, can also react with steam. So that tells us that this is the most reactive metal.
Okay.
That's why it can't decompose. The rest of them are able to decompose, meaning they are less reactive. Okay? And then the other thing is, can we also look at the reactivity with air? Look at this thing. This thing can't react with air, but can react with steam. So it's a little bit reactive, yet this one cannot react with air, cannot even react with steam. Therefore, X is the least reactive element.
Okay.
Is the least reactive because it cannot react with any of those things. But in a compound, when we heat them, they are able to decompose. Okay, they are able to decompose, they are able to decompose. But because they can't react, then they are the ones we're going to put at the very end. Okay.
Yes, sir.
Yes. Now, we are remaining with, so meaning we are saying, arrange them in increasing of the order. So we are starting with the least and we are ending with the most. And we are saying that the least is X. So we are starting with X here. We're gonna put an element here. We're gonna put an element here. And then at the end, that's where we're gonna put Oh, we are starting with the list, which is Y. So we are starting with Y here. We are starting with Y. And we're ending with the X, which is the list. So the question is, which of these two is coming second and which one is coming third? So we are only remaining with this one and that one. So what's going to help us to be guided is that look at these elements. One that reacts with air, one that reacts with air, Z can react with air, but W cannot. Therefore, which one is more reactive than the other?
Come again?
Look at W. W can't react with air, and yet
Yes.
Z can react with air. Which one is more reactive between the two?
Z is more reactive.
Yes, so meaning after W, we're going to have Z. And then, or after Y, we're going to have Z, then W is coming later. So, to sum it up, W and X are among the list. Why? Because they do not react with air among the list. But W is a bit reactive, I think we have switched. They are saying starting with the list. So the list here, the list is Y, followed by W, and then, no, let me know. It's like I'm mixing up. The question said, in the order of their reactivity. So we are actually starting with the list. Okay?
Yes, so it's ZY.
We are starting with the list. So the list here is actually X, because X cannot react in any way. So we are starting with X. After X, W follows. One of the reaction that X cannot react, even W can, but X reacts with steam, or W reacts with steam, so that is what is next. And then thirdly, we are going to go to Z. Z is a bit reactive, but not that much. Why? Because its compound decomposes. So we're going to follow Z. And then the last one is Y. Y is the most reactive. So most reactive because it can react with air, it can also react with steam, but its thermostability tells us that it's the most reactive. That is the increasing order of their reactivity. Are we okay now?
Yes.
Yeah. So that is what we need to understand. Then, because of this trend that they have portrayed, we can definitely suggest which element can be stored in oil. The reason for storing elements in oil, we want to prevent them from reacting with the air. We want to prevent them from reacting with the air. So any element that can react with air can be stored under oil. So we can clearly see here that Y or Z can react with air and therefore can be stored under oil. Are you seeing the reasoning there?
No, sir. Maybe repeat.
What I'm saying is, the question says which element can be stored under oil. The reason as to why we're storing them under oil is to prevent them from reacting with air. The reason as to why we're storing them under oil is to prevent them from reacting with the air. So the question is, which of these elements is able to react with air? It is Y and Z, isn't it?
Yes, sir.
Yeah, so they are the ones you can store in oil. But at most, the best, yeah, but you can still pick any of those, but the best answer could have been Z. Now, which element that we have to choose from those elements can be used to make ornaments? Can be used to make ornaments. So our reasoning here is that ornaments, these are trophies. And these trophies that we have, when they are made, should not be able to react with air. When they are made, should not even be able to react with water, because some of these ornaments, they may be spelled with water. So we have to make sure that the metal we are using can't react with air, cannot react with steam. Which element is that?
That cannot react with steam. That's X.
Yeah, so X was the best answer for that. This ornament cannot react with air. Look at it. What type of ornament will it be when you get this this ornament? You leave it here, and then tomorrow you find it has reacted with air. Then it's not adding any value. So we have to choose a metal which, when this ornament is made, it's able to stand a lifetime. Because some places are a little bit moist, find that the amount of water vapor in the atmosphere is quite high. So in a house, if we're gonna have water vapor in the house and this ornament comes in contact with what water, or maybe steam or some sort, we find that that ornament is going to melt. So the best thing is to go for a metal which can't react with any of these two. And then 3 says, choose a metal which can be extracted by electrolytic reduction of its own. Which metal can we extract using electrolysis?
We can use W.
W or even a, no. W, no. W is a metal that can, oh yeah, okay, W is okay. It's able to react with steam. Yeah, okay, those there we are at liberty. But the best answer that would go for is Z.
Okay.
Yeah. The best would go for Z and Y. You know what I'm saying?
No, sir.
It's because the electrolysis is the method that is used to extract the most reactive metals.
Yes.
Yeah, so which ones which one in the list that we have are the most reactive? We are picking only the last two in our series. So the most reactive are these ones here, Z and Y. Remember,
Yes.
from the activity series, the most reactive elements are the ones that we use to extract, the ones that can be extracted by electrolysis. So in our reactivity range there, we have to pick the most reactive elements.
Yes, sir.
Okay, then, so because of this, we can clearly indicate that element Y belongs to group 1, because group 1 elements are the ones that can react with air, are the ones that can react with cold water, are the ones that can react with steam, are the ones whose reactivity with the acids can be very, very dangerous. So, meaning element Y that we are talking about, is it element Y? No, element Y, yes, which is the most reactive element, belongs to group 1, meaning it has got a valence of 1. But now, most of the times, the things that I discovered in the answers that you guys were giving out is that when they say construct a chemical reaction between Y and cold water, meaning you have to show Y in the equation. Don't substitute Y with anything. They're talking about the reactivity of Y. So we actually gonna say that Y plus H2O We're gonna have an arrow somewhere there. We're gonna form YOH. YOH because cold water actually forms a hydroxide. Cold water, we are able to form a hydroxide. So if we are to supply the subscript, H2O is written like that, and the hydrogen is like that. So there are two things here. Construct a balanced, so just constructing an equation, you have 1 mark. Balancing it up, 1 mark, including state symbols, 1 mark. That's why this question had 3 marks. So the state symbol here, we understand that this is a solid, and then the water is liquid. Remember, they're talking about cold water. If it was gas, it could have been steam. So this is aqueous here. And we understand very well that hydrogen is a gas. So just these two things that I've written, you already have 2 marks. But the 3rd mark is when you balance it up. So the balancing here was not very hard to do. You just put a 2 here, you put a 2 there, and you also put a 2 there. And that's how the balancing was needed. So that's how 3 marks are supposed to be defended. Okay, then the last one says A, B, C. I don't know if it's D. Explain why non-metallic elements such as carbon and hydrogen are included in the reactivity series. Do you remember the explanation that I gave here?
No, sir.
I said that the reactivity series is only for metals, but even elements such as carbon and hydrogen are included. And the reasons as follows. When you look at the reactivity series, we said it's a reactivity containing metals. But among the metals that we have, we actually pick some few things. One, the methods by which these metals can be extracted. So the thing that guides us, which method to use. There are 3 methods, remember? So the element that guides us, which metals can be extracted by electrolysis, which element can also be extracted by reduction by carbon. The boundary that we have is carbon. So carbon is a reference. Actually, both of them are reference points. So carbon is a reference point for methods that can be extracted by electrolysis and reduction by carbon. So when you look at the reactivity series, where you're gonna find carbon, it means all the elements up can be extracted by electrolysis. And the ones that are below it are the metals that can be extracted by reduction by carbon. So carbon is a reference point. What about hydrogen? Hydrogen is also a reference point, except that what they refer to is a bit different. For hydrogen, the metal above hydrogen, the reactivity series, can react with acids, and those below hydrogen cannot react with the acids. So this one is also there to separate metals that react with the acids and those that cannot. So that's why these 2 elements are actually included in the reactivity series. So one is a reference point for metals that can react with acids. Then the other one is for the methods of extraction. Okay, we move on. Are we okay now?
Yes, sir.
Okay, first ask questions if at all they're there.
No questions.
Okay. So we go to question 3, which I saw a lot of reasoning from many and others lacked it. So question 3 actually says, the diagram below shows the reaction scheme for the extraction of a zinc from its metal ore. And this question was partly explained on the previous YouTube video. So you are actually going to lead the way. So we have two things here. First of all, it's a zinc blende which was roasted. And when it was roasted, these are the things that were formed. So what were formed was not actually a metal. I don't know, I might have made a mistake. But that's how the question came. It's a metal, it's a compound. Yeah, so metal ore is not just a metal, it's a compound, or it's an oxide rather, plus a gas. Now we understand that this is a gas, so when this gas is formed, it escapes, remaining with only metal A, which underwent the second part of the reaction. So someone was asking, sir, how possible is that the gas reacted? No, when the gas was formed, it was isolated. That which remained is the one that underwent the reduction by carbon to actually form a zinc metal and another gas. Now, this gas is different from the gas they asked. So the question says, identify the metal A and gas B.
Metal A, I put zinc oxide.
So metal A is zinc oxide, and gas B?
Sulfur dioxide.
And gas B is sulfur dioxide. Good, that's all right. And now, meaning when this zinc oxide was actually formed, is the one now that underwent reduction by carbon. So what is the chemical name for the zinc blende? What's the chemical name for zinc blende? And what is its chemical formula?
The chemical name for zinc blende is zinc sulfide. And the chemical formula is ZNS.
Zinc, it's zinc sulfide, and its chemical formula is
ZNS.
What is the S for?
Come again?
What is the S for?
Sulfide.
Huh?
Sulfide.
Sulfur. When sulfur reacts, it forms sulfide. So sulfide is actually just the sulfur. Yeah, okay. That's very good. And now C explains why gas B should not be allowed to escape into the atmosphere.
I wrote gas B, which is sulfur dioxide, produces acidic rain. This acidic rain is harmful to the environment and harmful. It kills their nutrients and minerals.
So it doesn't really kill per se, but and the way you have said that
removes.
At it forms, it produces.
No, what I said was gas B, which is sulfur dioxide, produces acidic rain.
That's there. It's not just the gas that produces. You know what it means when you say it produces? It means within its own chemical constituents, something comes up. But that's not the quite answer to say. It is when this gas reacts with water during condensation. So it is the sulfur dioxide, subscript 2, when it reacts with H2O, that's when sulfurous acid is produced. So it's not just the gas itself that produces. I'm trying to tell you, I'm trying to guide you on how to answer these questions smartly. It's not just the gas that produces, it is when that gas reacts. Remember talking about escaping to the atmosphere, and when it goes above there, during cloud formation, during the condensation period, that is when the rain is formed. So the best that would say is that it leads to the formation of acidic rains. Acidic rains which can cause, now there are anything you bring out to do with damaging of the vegetation, changing the pH of the soil. So now, because the question did not actually ask you to explain on the effects, the best that would just say is that it leads to the formation of acidic rains. Kwasila. Unless
Yes, sir.
question went as far as asking you what are the environmental effects.
Yes.
Yeah. Now, when the question goes as far as asking about environmental effects, that's when you can gladly now bring in those other things. But the question says why it should not be allowed? It's because it can lead to the formation of acidic rains and save on the time.
Yes, sir.
Yeah. So remember here, it was just a single mark. So you don't need to explain putting up paragraphs and stuff like that. Okay. Discuss the stability of group 1 metal carbonates on heat. What did you say and what is it that you have in your mind?
I said group 1 elements, e.g. lithium and sodium, are highly reactive when exposed to heat.
Okay.
Yes, sir.
So the question was a little bit okay, but somehow uncentered. So the best that would say is that actually lithium on hydroxides, is it on nitrates? It decomposes. Yeah. So, but the best that you would just say is that they are thermally stable, which do not decompose on heat. They are, or they form stable compounds that do not decompose on heat. If you are to explain more, you can even say except for lithium. Remember, why have we brought out these exceptions? It's because, remember, the reactivity of group 1 elements increases as you go down. So, meaning the metal up, which is the carbonate, is less reactive. As a result, its thermostability is not as good as those for the elements that are up. Okay?
Yes, sir.
So
Yes.
the reactivity of group 1 element increases as you go down. So meaning the element up, which is lithium, the thermostability that it has is not as much as it is for the rest of the metals that are found in the group as you go up. Now the down. Now the last one is, let me just talk about what are the uses of zinc. Because the work that I'm going to give you, I want you to explain on the uses of zinc. So I'm going to send you work. I want you to focus on the uses of zinc and then maybe just try to see how best you can read about it.
All right.
Okay, so I can end here.
All right, so
I hope.
do you still have my book?
Yes, I do. Oh, unfortunately,